aspirants, welcome back to our channel AgriVision for you. So with this GATE 2025 application forms, it's the perfect time to ramp up your preparation. Now AgriVision for you is here to help you with our previous year question series. Now where we'll break down the past GATE questions and provide you the detailed explanation. So in my first video of GATE XE 2023 first part, I have discussed the first 11 questions, and in this video I'll be discussing the next 11 questions. So if you have not watched that previous video, first go and watch that. Now if you are new here, subscribe to our channel and hit the bell icon for regular exam updates and tips. And also don't miss our dedicated batch for GATE XE Excel 2025. Enroll now using my code, that is AgriJ50, for a flat 50% discount. Now let's dive into our today's session of GATE XE 2023 second part. So first question, that is identify the gram-positive bacteria which is responsible for causing foodborne diseases among the following. So first option, that is Campylobacter jejuni. Second option, Clostridium botulinum, Vibrio cholerae or Salmonella typhi. So Campylobacter jejuni, we know that it's a gram-negative bacteria. So it's a gram-negative bacteria and it causes a disease, that is Campylobacteriosis. Next, Clostridium botulinum. So it's a gram-positive bacteria which causes botulinism in severe cases. Next, Vibrio cholerae. It's a gram-negative bacteria and it causes a disease, that is cholera. Severe extent, it can cause diarrhea, nausea. Next, Salmonella typhi. It's a gram-negative bacteria which causes typhoid. Infections, systematic infections we can say. So over here they have asked gram-positive. So my correct answer should be option number B. Next question, extrusion cooking is accomplished in 4 different stages, which are indicated as 1, 2, 3 and 4 in the figure given below. Choose the correct option representing the name of each stage. Okay. So in the extrusion process, first feeding is done. So first feeding is done. Then after that, feeding means raw materials are introduced into the extruder. Next, after that, kneading is done. It should be kneaded. That means the material which are mixed, heated, which creates a dough-like consistency. After that, cooking. So the dough which is further heated, it should be cooked to a desired temperature. And then last stage should be the expansion. That means the cooked material is now forced through a die, causing to we can say to expand or form a desired shape. So which option should be correct over here? Option number C, that is feeding, kneading, cooking and expansion. Next question, match the method or the value which is used in measuring the lipid characteristics in column 1 with the corresponding properties indicated by them in column 2. So first column, that is the thiobarbituric acid test. So actually this thiobarbituric acid test, it is used to measure the formation of carbonyl compounds, which are the products of lipid oxidations. So it should be number 3. Next one, that is Ransimet test. So Ransimet test, basically it measures the time it takes for a lipid to reach a certain level of oxidation. That means it is the induction time we can say. Peroxide value. So peroxide value, basically it measures the amount of hydroperoxides which are present in the lipids. We can say which are the primary oxidation products. So therefore it indicates the hydroperoxide contains. Next one, that is iodine value. So iodine value, that means it measures the degree of unsaturation in a lipid. Means it determines the amount of iodine that can react with its double bonds. So this indicates the degree of unsaturation. So which option should be correct? P3Q1R4S2. Option number A should be correct. Next question, Match the peeling technique in column 1 with the vegetable for which it is used in the industry given in column 2. Okay, so first one, that is knife peeling. So knife peeling, actually it is a technique which is used for vegetables with thick, or we can say tough skins, like the cucumbers. So this is option number 4. Next, abrasion peeling. So abrasion peeling, basically abrasion means what? Uneven surface. Now uneven surface किसमें हो सकता है? So basically it is the technique which is involved in rubbing the vegetable against a rough surface to remove the skins. So it is potato. Next, flame peeling. Flame peeling, this technique, it involves basically the exposure of the vegetable to a flame to loosen the skins. So this we have also done in our home. This flame peeling tests for the brinjals basically. So it should be option number R. And next, the flash peeling. So this technique, basically it involves quickly immersion of the vegetable in the hot, warm, or we can say steam to loosen the skins, which is followed by cold water rinse. It is commonly used for, so which option is correct? Option number D, P4, Q3, R1, S2. Next question, match the process in column 1 with the related food component in column 2. First one, that is caramelization. So caramelization, we have studied this about n number of times. What is it? It is a process which involves the breakdown of sugar into the complex mixtures of compounds, which gives it a brown color or a sweet caramel flavor. So it is basically related to sugars. Next one, denaturation. So denaturation, it is a process which involves the disruption of the protein structures. So often it is caused by the heat or the pH changes. So basically denaturation occurs in enzymes. Oxidation. So oxidation, this is involved in, actually this process involves the reaction of a substance with the oxygen. So it leads to the change in the color, flavor, textures. So oxidation, basically lipid, for lipids. And next, that is bleaching. So bleaching, it's the removal of the color from the food, which is often used by the chemical agents. So it is about the pigments. So which option is correct? Option number A, that is P2, Q4, R1, S3. Next question, identify the correct statements related to the grain polysaccharides among the following. So first one, that is dextrins are a group of low molecular weight polysaccharides produced by starch, dry hydrolysis of starch. So we know what are dextrins. Okay, we have to mark the correct statements. So dextrins, these are actually the smaller starch fragments which are produced by breaking down starch molecules. So this statement is correct since dextrins, these are actually the group of low molecular weight polysaccharides which are produced by dry hydrolysis of the starch. Next one, amylose is a linear polymer of D-glucose units joined by alpha-1,6-glucoside linkage. So what we have studied in our class, that amylose, it is a linear polymer of D-glucose unit which are joined by alpha-4 glycosidic linkages, not 1,6. So this statement is not correct. Next one, aminopectin is a branched chain polymer of D-galactose monomer unit. Now what we have studied, that amylopectin, it is a branched chain polymer of D-glucose monomer. So it should be D-glucose monomer units, not D-galactose. So this is not correct. Next, retrogradation is a process of reassociation of amylose and formation of crystalline structures by gelatinized starch upon cooling. So yes, this is correct. Since gelatin, actually this retrogradation, it is the process where this gelatinized starch, it reforms a crystalline structure after cooling. So which causes it to become firm. So this is correct. So which two options are correct? Option number A and next question. Identify the correct pairs of governing law with respective process operation. So first one, Stokes law, that is mass transfer. So what we have studied in our class, Stokes law. So Stokes law, it's not directly related to the mass transfer. Rather, it is primarily used in fluid mechanics to describe the settling velocity of a particle in a fluid. So it's basically about the settling velocity. Next one, Kirchhoff's law, that is radiation heat transfer. So what we have studied about Kirchhoff's law? Kirchhoff's law, it states that a body's ability to emit radiation, it is directly related to its ability to absorb radiation. इसका मतलब क्या है? That is, a good absorber is also a good emitter. So this is correct. Next one, that is Fourier's law, that is conduction heat transfer. So Fourier's law means heat flows from hotter region to a colder region, and the rate of heat flow, it is proportional to the temperature difference. This is correct. Next, Fick's law, that is molecular diffusion. So Fick's law हमने क्या पढ़ा है? That it's if a substance it moves from area of higher concentration to the area of lower concentration, the rate of diffusion, it is proportional to the concentration gradient. It's about the molecular diffusion. So this is also correct. So our correct options are B, C and D. So our next question, a hammer mill is used to grind black gram. Now the size distribution of black gram is such that 80% pass through a 6 mesh particle size, which is 3.36 mm screen. The power requirement to produce a powder is 80%, of which passes through a 45 mesh particle size of 0.354 mm screen, that is 4.5 kilowatt. Now the power in kilowatt required to produce a finer powder of 80%, of which passes through a 60 mesh particle size of 0.25 mm will be how much? We have to calculate and round off to 2 decimal places. So assume that the feed rate of to the mill is constant in both the cases. You have to use Bond's law of size reduction. So what is Bond's law? So Bond's law, it states that the energy which is required to reduce the particles to a certain size is proportional to the square root of the surface to volume ratio of the product. That means P, it is equal to the constant of D2 minus 1 by root over of D1. So what is P over here? It is the power required. K, it is the constant of the material. D2, it is the final particle size, and D1, it is the initial particle size. So in our first case, we have to calculate the constant, that is K. So for calculating K, put all the other values, that is 4.5 by what is D2? 0.354 root over minus root over 3.36. So you will get an approx value, that is 2.25. Now we have to you have to use this K value to calculate for our second case, to calculate the value of P2. So over here P2, which is K into 1 by root over d2 minus 1 by root over d1. So K, it is 2.25, which we have calculated. D2, it will be 0.25 for the second case, minus 1 by root over uh, 3.36. So you will get an approx value of 5.33 kilowatt. So the power which is required to produce a finer powder, that is 80% of which passes through a 60 mesh screen, is approximately 5.33 kilowatt. Next question, if D10 for salmonella in egg yolk is 0.75 kilogram, calculate the radiation dosage in kilogram, round off to 2 decimal places, required for reducing the salmonella count in egg yolk by 8 log cycles. Now, D10 for salmonella in egg yolk is 0.75 kilogram. So we have to reduce it by 8 log cycles. So we have to reduce it by 8 log cycle. Now we know that 1D reduction, it means that 1 log cycle reduction. So to reduce the microbial load by 8 log cycle, it means that we have to reduce it to 8D value. So the required dosage will be required dosage will be 8 into D10 into 2.303. Now we know that ln E, that is natural log, it is 2.303 into log 10. That means it is 8 into D10 is 0.75 into the log value. So it will be approx 13.818 kilogram. Next question. The average moisture binding energy of a plant protein based snacks is 8% moisture content, dry basis is 3200 calorie per mole. If the water activity of the snack at the above moisture content is 0.3, at 30 degrees Celsius, the water activity of the sample at 45 degree will be how much? And we have to round it off to 2 decimal places. So the value of gas constant is given, that is R equal to 1.987 calorie per mole per Kelvin. So first we have to know the moisture binding energy. So what is it? Which is the energy required to remove water from the food. It is known as moisture binding energy. And what is water activity? It is a measure of the availability of water in the food. So we know a formula, that is ln of water activity, that is minus delta H by RT plus C. So what is this? This is the moisture binding energy. Moisture binding energy. R, it's the gas constant. T is our constant. T is temperature. So we have water activity delta H R T at 30 degrees Celsius. Now for we have to convert this Celsius to Kelvin. So how will we will be converting? So 30 plus 273.15. So it will be 303.15 Kelvin. Next C, so we have to calculate it, that is ln of water activity plus delta H by RT, that is ln of 0.30 plus 3200 divided by 1.987 into 303.15. So after calculating, we'll get approx 13.96. Now we have to calculate it. This is for 30 degree. Now we have to calculate it for 45 degrees Celsius. So 45 degrees Celsius, we have to first convert it. 45 plus 273.15. So it will be 318.15 Kelvin. So ln of water activity, that is minus delta HB by RT plus C, that is minus 3200 by 1.987 into 318.15 plus the constant which we have calculated, that is 13.96. So we'll get an approx value of 0.33. So this is your approx value. So therefore the water activity of sample at 45 degrees Celsius is approximately 0.33. Next, the last question. Cow milk is pasteurized at a flow rate of 1 kg per second in a counter-current heat exchanger using hot water as the heating medium. The milk enters the heat exchanger at 15 degrees Celsius, exits at 50 degrees Celsius. The specific heat of cow milk is 3.5 kJ per kg per degree Celsius, and it remains constant at the inlet and exit of the heat exchanger. The inlet and exit temperature of the hot milk are 75 degrees Celsius and 60 degrees Celsius respectively. If the overall heat transfer coefficient is 1800 watt per meter square degree per degree Celsius, the heat transfer surface area in meter square will be how much? We have to round it off to 2 decimal places and we have to assume a steady state conditions. Okay. So flow rate of milk, it is given 1 kg per second. Inlet temperature is 15 degree, outlet temperature 50 degree. Specific heat of milk is 3.5. Inlet temperature of hot water, that is 75 degree, and outlet is 60 degree. And overall heat transfer coefficient, that is U, it is given 1800. So what is counter current heat exchanger first? Actually, it is a type of heat exchanger where the two fluids flow in opposite direction. Counter current means opposite direction. And we know a formula, that is heat transfer equation, that is Q, which is equal to U into A into delta T Lm. Q, it is heat transfer rate. U, overall heat transfer coefficient. A, the heat transfer area, surface area, and delta T Lm, it is a logarithmic mean transfer difference. So first we have to calculate heat transfer rate, that is Q. So for calculating Q, we'll use the formula, that is mCp delta T. So mCp delta T. Delta T means temperature out minus temperature in. So we have to calculate M, that is 1 kg per second, into Cp 3500 joule per kg degree Celsius, temperature that is 50 minus 15 degrees Celsius. So we'll get 122,500 watt. Now we have to calculate the logarithmic mean temperature difference, that is delta T Lm. So for calculating delta T Lm, that is delta T1 minus delta T2 by ln delta T1 by delta T2. So T1, how to calculate del T1? It is 75 minus 15, that is 25 degrees Celsius, and del T2, it will be 60 degrees Celsius minus 15 degrees Celsius, it is 45 degrees Celsius. Now just put the value over here. 25 minus 45 by ln 25 by 45. You'll get it approx 34.17 degrees Celsius. Now just put all this in heat transfer surface area, that is A. So I'll write over here A, that is Q by this formula only, U into delta T Lm. Calculate it. 122,500 watt divided by U. What is it? 1800 into 3417. 34.17. So after calculating, we'll get approx 2 meters square. So the heat transfer surface area which is required, it is approximately 2 meter square. So with this we have completed our solutions for GATE XE 2023 second part. So if you like our video, do share with your friends, subscribe. Until then, enjoy learning. Thank you.